Hi, welcome to my follow-up video on Pythagorean Theorem. The first Pythagorean Theorem video should be watched first, and then this one is sort of like a consolidation to that, a little bit of a follow-up just to kind of fine-tune some of the concepts there. So I mentioned before that Pythagoras noted that when he drew squares off of the sides of the two legs and the hypotenuse of a right triangle, that the areas of the two squares off the legs of the triangle added up to the area of the square off the hypotenuse. So that's all fine and good, and we've looked at that. We'll look at it again a little bit later, but first of all I want to let's go back a little bit and start looking at some squares again. The squares are fun to calculate the areas of. So if you take a look at this square, I've drawn that perfectly on the grid lines here. So we see that the side lengths are 2 units each, and therefore we know the area of a square is, the formula is s squared, and this we quickly developed from in the video of the properties of quadrilaterals. And so area is s squared. We know that the side length, because these are squares, all the side lengths are the same. So we can say that the side length, all being 2, the side length of each one of those is 2. So the side length squared is 2 squared, which gives you 4. And that would be square units. If we look at this next square, we see that the side lengths are 3 units each, and again the area, the formula is a equals s squared. We know the side length of each of the sides all the way around is 3 units, so that would be 3 squared, and so the area would be 9 units squared. Okay, in that case. And here we've got a larger square. We see as 1, 2, 3, 4, 5, 6. So these are 6 units in length, each of the sides. We know it's a square, of course, so each of the side lengths are the same length, or the same. And so area, of course, being side squared, would be 6 squared, which is 36 square units. Okay, so now what if we're just given some square, and we see that the area is, in this case, 36 square units. Well, in order to back this up, to find the side length, well, we know that area is side squared. So if we're given the area, and we know that area was calculated by taking the side length and squaring it, if we then take the square root of the area, or a square root of both sides, because it is a sorry, stumbling on my words here. This is an equation. We have to do the same thing to both sides, and it might be evident to you, or it might be familiar to you, that the opposite of a square is actually a square root. So if we take the square root of both sides of the area formula, the square and the square root cancel. So then that means that the side length is actually going to be the square root of the area. So if we take this example, we know that the area here in the square is 36. And we know that equals side squared, which is the area. And by taking the square root of both sides, then we know that the side length is equal to the square root of 36. And because we're talking about lengths, we're not going to worry about plus or minus here, because it's a distance. The distance is just going to be a positive value, or a length, I guess. The side length is the square root of 36, which means it's 6 units long. Okay, so we've gone from area, if we know the side lengths, and we can find the area of the whole square. Now if we're given the area of the square, we can back it up and find the side length of this square. So the dimensions of the square, so the square in this case would be 6 by 6, we can find the side length of that square. If we come over here to the smaller square here, we can do the same sort of thing. We know the area is 9 square units. We know the area is calculated by saying side squared. And if we take the square root of both sides, the square and the square root cancel, so we're left with the side length is the square root of 9. So therefore the side length of the square with area of 9 square units is 3 units long. Okay, units could be centimeters, millimeters, kilometers, light years, whatever it may be. But we have the side length by taking the square root of the area. Okay, and we could back this up again over here. The area is 4 square units. The area is calculated by taking the side length squared. And so we take the square root of both sides. So the side length is 2 units. Okay, so this will occur for any sort of square, regardless of the actual side length, regardless if it's a perfect square or not. Like these ones are all perfect squares, so it made things a lot easier. But suppose we have a square that's not matched up right on the grid, so we can't actually even count the side lengths. And let's say, for example, the area of this is, I don't know, let's say 116, not square centimeters, because we don't really know it's centimeters, let's say square units. So if we know the area of this square is 116 square units, and we know that the area is calculated by taking the side length and squaring it, then we can replace the area with side squared. Then we take the square root of both sides again, and the square root, or so the side length, is the square root of 116. And now pulling up my calculator that I've had since I was in, I believe, grade 13, so that of course dates it. We know that the area of the square is 116 square units, and we take the square root of that, and we get 10.77 approximately. So you could maybe round it to 1 decimal place if you wish. It's less accurate that way, but that would be the length of the side of that square whose area is 116 square units. Now let's go one step further now. Now that we have this square here, let's say that that square is actually the hypotenuse of a triangle. So we now know that that square matches up with the hypotenuse of this triangle. It's a right triangle. Then what we need to do is we need to say, okay, well, if the area of that square is 116 square units, and we just found the side length of that square, and the side length is approximately 10.8 units. Well, then if it's a side length, then that means that this side length is going to be 10.8 units. And that side length of the square matches up perfectly with the length of the hypotenuse, which now tells us that the length of this hypotenuse of the triangle that I just drew on the edge of that square is 10.8 units long. Now let's suppose now that we've got, how many? 1, 2, 3, 4, 5. So we've got 1, 2, 3, 4, 5 here. Now this probably will not work out because I just made up values. So it's very unlikely that this will work out perfectly. But let's say now that we have another square here, and let's say that this square had an area of, I don't know what might be reasonable, let's say 36, no, let's say 35 square units. So the side length, or the side squared, is 35 because that's the formula for area. And of course then we take the square root of that. So the side length of the square with area 35 square units, and again I'll pull this bad boy up here, 35, the square root is 5.916. So I'll just round it to 5.92 to three significant figures. So I'm just going to say that this is 5.92. I know this is 10.8. I could maybe just say 5.9, but let's say that this square has a side length of 5.92 units for a side length. And so, of course, if the side length of the square is 5.92, that means that this side is also 5.92 units, which means that because this square matches up, this side of the square matches up perfectly with the leg of this triangle, then that means that the leg of this triangle has got to be 5.92 units in length as well. Okay, so now thinking back to Pythagoras, we go back here and we're going to draw another square. 2, 4, 6, 7. 2, 4, 6, 7. So I'll draw a square to make it as accurate as possible. And so these are just squares, they're representing different lengths, but so we know that from Pythagorean Theorem, and I've used this before, we know that this is the longest side, the hypotenuse is the longest side, and we know that the area of this square, so the square where the side length of the square is the length of the hypotenuse, that's the side length, is equal to the square off the shorter side of the triangle plus the area, sorry, we should be saying areas, area of the square off the medium side. So this is our L squared, this is S squared, so these are the areas of the largest square, area of the smallest square, and here's the area of the medium squared right here. So we know that if we were to take the areas of these two squares and we add them together, we will get then the area of the largest square. So in this case, however, we have the area already of the largest square, which means that we were able to find the length of the hypotenuse, and we have the area of the smallest square, which means that we have the side length of the shorter side of the triangle, the shortest leg of the triangle here. Now we need to find, first of all, the area of this medium size square, and then use that to find the side length, the missing side length of this triangle, this right triangle. So if I know that these two small the areas of these two smaller squares add up to give me the area of the largest square, then that means that if I know the area of the smallest square and the area of the largest square, there's no way I can add these two together to get the area of the medium square. The only way I can get the area of the medium square is if I were to take this area of the smallest square and subtract it, suppose it were to fit in here somewhere, if I were to take the area of the smaller square and subtract it, cut it out of the larger square, what's remaining, if I were to reassemble this, what's remaining with all this space would fit into this square down here on the medium side. So I actually have to, in order to find the medium side squared, I would have to actually subtract the area of the shorter side from the area of the larger side. So I have to subtract the areas, and because it's an equation, we have to do the same thing to both sides. So I'm going to first form zero pairs. Okay, form a zero pair by subtracting s squared from both sides. And so s squared minus s squared gives me 0, which leaves me with just m squared on the right side of the equal sign. And then I've got l squared minus s squared. And so we know L squared, so the area of the largest squared is 116, as I stated up there. The area of the smallest side is 35. And that will then leave me, because if I'm subtracting the area of the smallest square from the area of the larger square, that's going to leave me with this area that will give me the area of the medium side squared. And so then I take 116 and I subtract 35. So that gives me 81 square units for the medium side. It's the area of the medium square. And then I take the square root of both sides, and as luck would have it, I'm not sure how that worked out so nicely, I take the square root of both sides, so the squared and the square root cancel out, so we're just left with m, which is the side length of this square, and that gives me 9. So by taking the area of the smallest square and subtracting that from the area of the largest square, I will then get the area of the medium square. And just to check this then, what I could do is I could go back in here and I could say, well, let's see if this all works out correctly. So I've got Pythagorean theorem. The area of the largest square is equal to the area of the smaller square plus the area of the medium sized square. And so the smallest square's area is 35, and the medium side squared was 81. And so when I add those together, I end up getting 116 square units, which was the area to begin with of the larger square. So if the sum of the squares of the two legs of the right triangle add up to give you the area of the square of the hypotenuse, then that means that you've done your work correctly. Alright, let's just take a look one more time, and we'll do this in a very, very old-fashioned method, but we'll take a look at one more little example of this, which I will set up in a moment, and I will show you what we have. So here we have a right triangle, and I'm keeping it as simple as I can because I didn't want to be cutting out little squares of post-it notes forever. But here we have a square off a right triangle, and the hypotenuse of the right triangle is 5 centimeters, and that means that the area of the large square, and I will change that to L squared. L squared is then 25 square centimeters. Suppose we know that the short side here is 3 centimeters. So we know this is 3 centimeters. And we need to find the medium side squared, or the medium side, the length of the medium side of the right triangle. So we know that this leg is 3 centimeters. So therefore the square that would be formed here should be 9 square centimeters. Okay, so in order to find m squared, we need to take the area of the large square, subtract off enough of this area to build up the area of the small square, and then whatever's remaining will be the area of the medium side. Okay, so I kept this small on purpose because I didn't want it to be taking forever to do this. Here's that last piece. Sorry, I was concentrating so much I didn't shift the paper for you. But you can see that after subtracting the area of the small square from the area of the large square, we then were left over with the area of the medium squared. Okay, so given the length of the hypotenuse, you would subtract the area of the square of whichever leg you are given, and that will then give you the area of the square of the other leg, and then by taking the square root of that, in this case, m squared equals 16, therefore m is going to equal 4 centimeters. Alright, so thank you for watching, and we'll see you next time.